Imagine looking up at the night sky and seeing Orion's belt not as three blazing suns, but as three colossal wandering worlds. What would happen if the heavens swapped light for mass? If those blue giant stars were replaced by planets of unimaginable scale? The balance of an entire region of space would be shattered in an instant, and the consequences would ripple across the cosmos. In the abyss of space, three lights aligned, as if they guarded a perfect order. Yet those lights are not immutable. They are merely concentrations of mass and energy. Replace Mintaka, Alnilam, and Alnitak with three massive gas giants, each dwarfing Jupiter, and the gravitational potential of the Orion sector is rewritten. The mutual attraction of these titanic bodies would dominate the local field, pulling nearby nebula filaments and reshaping the trajectories of any wandering debris. First, consider the outermost position, the realm of the extreme ring giant. Imagine a super Jupiter 10 times more massive than any planet we have ever catalogued. Adrift without a host star, deprived of stellar heat, it would rely on Kelvin-Helmholtz contraction, slowly converting gravitational energy into internal heat. Its rings, 1,000,000 kilometers wide and inclined to its orbital plane, would act as a vast net, capturing the tenuous gas of the surrounding nebula. Each captured particle would be funneled into the planet's magnetosphere, igniting perpetual auroras that dance across the polar caps like living curtains of light. In the darkness of interstellar space, those auroras would become the only beacon, a luminous veil that marks the planet's lonely path. At the center of the alignment lies a world of fire and plasma, a rocky gaseous titan subjected to extreme tidal forces. Visualize a surface where solid crust cannot endure, where molten rock pools merge into oceans of lava that stretch for thousands of kilometers. Charged particles from nearby nebulae would be accelerated along magnetic field lines, spawning plasma storms of such magnitude that they would scar the horizon with arcs of incandescent fury. The planet's gravity would be insufficient to hold a stable atmosphere, yet the constant bombardment of interstellar radiation would keep the surface in a state of perpetual upheaval, a crucible forged by the raw forces of the deep cosmos. Now, picture the surrounding nebula, known to astronomers as the Flame and Horsehead, slowly advancing, its clouds of dust and gas enveloping the trio. Without the stellar winds of massive stars to disperse this material, the planets would begin to accrete the nebula gas. Their cores would swell, temperatures would climb, and one of them could cross the deuterium burning threshold, birthing a brown dwarf in a matter of millennia. This sudden increase in mass would alter the gravitational dance, pulling the remaining worlds onto divergent paths. If this is blowing your mind, hit subscribe and let me know what you think in the comments, because the story of these wandering giants is only just beginning. The nebula veil does not simply pause, it presses inward, a slow tide of cold dust and ionized plasma that reshapes every surface it touches. As the gas collapses onto the massive cores, the gravitational well deepens and the surrounding space feels the new pull. The once tight line of the three wandering titans begins to stretch, each planet feeling a slightly different tug from the growing brown dwarf that now glows faintly in the infrared, a newborn ember in the darkness. Imagine the outermost world, the extreme ring giant, now cloaked in a thick shroud of accreted material. Its rings, once a delicate lattice of dust and ice, become a dense, opaque disk that absorbs starlight from distant neighbors and re-radiates it as a warm, amber glow. The planet's own heat, generated by the relentless contraction of its interior, combines with the infalling gas to create a convective storm that churns the upper atmosphere into bands of swirling amber and violet. From a distance, the object would appear as a slow spinning lantern, a beacon for any future traveler daring enough to venture into the Orion arm. The central fire and plasma world, meanwhile, undergoes a more violent metamorphosis. The influx of nebular material fuels a runaway reaction in its molten mantle. As fresh hydrogen and helium are forced into the core, the temperature spikes, igniting brief, localized bursts of nuclear fusion that flicker like distant suns. These microflares erupt across the surface, sending jets of superheated plasma into the surrounding void. The planet's magnetic field, already stretched to its limits, snaps and reforms in a chaotic dance, producing auroral curtains that wrap the entire sphere in a perpetual, shimmering veil. Yet, despite this brief flare of brilliance, the planet cannot retain a stable atmosphere. The constant bombardment of high-energy particles strips away any nascent gases, leaving a world that is both a furnace and a vacuum. Further out, the third wanderer, once a solitary super-Jupiter, finds its destiny altered by the growing brown dwarf's gravity. The brown dwarf's pull begins to dominate the local dynamics, drawing the massive planet into an elongated, eccentric orbit that swings it far from the dense nebula core and then plunges it back into the thickest regions of gas. Each close passage adds layers of material to the planet's envelope, inflating it into a bloated, low-density sphere that resembles a giant floating balloon. Over millions of years, the planet's mass increases enough to trigger a brief phase of deuterium burning of its own, turning it into a secondary brown dwarf that shares the sky with its older sibling. The two brown dwarfs, locked in a slow, gravitational waltz, become the new anchors of the system, while the remaining planetary remnants drift away, their trajectories forever altered. Now consider the passage of time on a galactic scale. As the Milky Way rotates, the three remnants, two brown dwarfs and a solitary, icy wanderer, are carried along the spiral arm, each following its own path through the stellar sea. The once perfect alignment of the Orion belt dissolves into a scattering of objects separated by thousands of light years. Gravitational encounters with passing stars, molecular clouds, and the galactic tide nudge them further apart, ensuring that the original configuration will never reappear. In the vastness of the galaxy, these bodies become mere specks, their histories recorded only in the faint signatures they leave in the interstellar medium. One of the planets, stripped of its massive envelope, cools rapidly as it drifts into a region of space far from any significant heat source. Its surface, once a roiling sea of magma, solidifies into a crust of frozen silicates, a dark, silent world that reflects only the faint glow of distant stars. Over eons, this icy planet may capture a thin veil of hydrogen, forming a tenuous atmosphere that could, in theory, support a fleeting chemistry of simple molecules. Yet, without a star to provide steady energy, any such chemistry remains locked in a state of perpetual stasis, a reminder of the fleeting nature of planetary habitability. The other brown dwarf, having accreted enough mass to ignite deuterium, shines dimly in the infrared, a substellar ember that will eventually cool and fade, joining the ranks of countless brown dwarfs that pepper the galaxy. Its presence, however, may seed the formation of a future star cluster, as its gravity continues to draw in surrounding gas and dust. In this way, the original trio of massive planets becomes the catalyst for a new generation of stellar birth, a cycle of destruction and creation that echoes throughout the cosmos. What does this thought experiment tell us about the universe? It reminds us that the patterns we perceive, such as the neat line of Orion's belt, are often fragile, momentary alignments in a sea of constant change. The cosmos is not a static tableau, but a dynamic, ever-evolving tapestry where massive bodies can be reshaped, reborn, or erased by the relentless forces of gravity, radiation, and time. The illusion of permanence we project onto the night sky is, in truth, a fleeting snapshot of a universe in perpetual motion. If you have followed this journey from luminous stars to wandering giants, from fiery plasma seas to the quiet birth of brown dwarfs, you have glimpsed the profound interconnectedness of cosmic events. The story does not end here. Each hypothesis opens a new corridor of questions. How might other stellar constellations behave under similar conditions? Could rogue planets like these ever host life, however brief? And what does the inevitable drift of such massive bodies tell us about the future of our own solar system? I invite you to share your thoughts in the comments below. Which part of this cosmic saga resonated most with you? Do you think the universe is more chaotic or more ordered than we imagine? Your insights help shape the next exploration we undertake together. If this exploration sparked your curiosity, consider joining the community of seekers who venture beyond the familiar constellations. Subscribe, like, and stay tuned for the next deep dive into the mysteries that lie hidden among the stars. The cosmos awaits, and together we will continue to unravel its endless secrets.